So hey guys, this is Dipesh, and in this particular video we'll be implementing k nearest neighbors algorithm or k nearest neighbors model in Python. Okay, more specifically we'll try to solve a regression problem, and the dataset that I will be using in this particular video is the same dataset that we used in linear regression video. Okay, so also don't worry about the code. If you go to GitHub, if you go on my profile, you will see that I have a repository called as MLDL course. Okay, MLDL course. So I have uploaded code for each and every lecture. So even if you don't get it in this video, what you can do is you can just download the code on your local machine and you can play around with it. So yeah, let's get started. So the first and foremost thing that we'll do is we'll import some of the necessary libraries. So we'll import NumPy, we'll import pandas, we'll also import matplotlib since we would be creating a plot, and another one we have to import is the train test split method. So what we'll be using that method to split our dataset into training and testing set. And the last and the final thing that we have to import is the KNN regressor, okay, from sklearn library. So rather than writing it, let me just copy this and paste it. Okay, so from sklearn dot neighbors we have imported k neighbors regressor. Now I have imported k neighbors regressor because we will be solving a regression problem here. If you are trying to solve a classification problem, try to import a k neighbors classifier. Okay, now let me add some more cells here. Okay, so let's run this and import them. Another thing that we'll do is we'll try to read our dataset here. So I will quickly go and copy the path of the dataset on my local machine. It is the same dataset, same salary dataset that we used in the linear regression problem. Okay, I will also be uploading this dataset on GitHub. So don't worry, just download this dataset from my GitHub. So let's read this. So what we'll do is we'll do df is equal to pd dot read csv. We'll give it our path, and let's also print the first 10 samples from the dataset. So as you can see, we have two columns. First is years of experience and the second is salary. So what we'll do is we'll try to predict salary given years of experience. So years of experience is basically our x and salary is our y. So let's create our x and y. So x would be df years experience, and our y would be df salary. Okay, so let's print some of the values. Okay, I think I made some. Okay, there's an s here. Let's run it again. All right. Also, since we are having one feature, okay, since we are having only one variable, independent variable here, what we have to do is we have to reshape our x here. Reshaping x. So what we'll do is we'll do x is equal to np dot array. We'll pass it our x and then we'll reshape it. We'll reshape it to 1 minus 1. Alright, let's run it and again let's print it. Alright, so the next thing that we'll do is we'll split our data set. What I'll do is I'll try splitting data set, and we'll be using the train test split method here. Okay, so the train test split method will automatically return us our x train, our x test, y train, and our y test. And this method just takes three main components. First it will take our x, and then it will take y, and the third important thing it will take is the percentage of our test data set, that is the size of our test data set. So I'll be dividing this into a 70 to 30 ratio. So 70% of the data would be used for training, and 30% of the data would be used for testing. So that's why I gave it 0.3 here. So again, let's print our x test. Okay, what it is saying is found input variables with inconsistent number of samples. Okay, I think there may be a mistake here. What I will do is we'll change it to -1 and 1. Okay, let's run it again. Alright, so now we can see that the one mistake where one thing where we made a mistake is, rather than reshaping it to -1 and 1, we did the opposite thing. So that was a minor mistake there. Now we have successfully splitted our data set into train set and test set. So now the last thing that we have to do is we have to train our model. So what I will do is I'll write training the model here. Okay, now the now training our model is very easy. All we have to do is write model is equal to where is that method. Okay, so we'll take this function and we'll just implement it here. Now one important argument that this method takes is n neighbors. Okay, n neighbors is basically n neighbors is basically the value of k. Okay, so let me write here n neighbors is equal to k. Okay, just for the sake of simplicity I'm giving a random value here. Okay, after once we have trained this and once we have seen how this works, we will try to find the most optimal value of k for our model. Okay, so let's now the next thing we'll do is we'll train our model. We'll do model dot fit, and I'll pass our x train and our y train. So let's run it. Okay, so our model has trained. Now what we can do is we can use this model to make our predictions. So for example, since we have printed our x test, let me also print our y test so that we can confirm the real values here. So I'll print y test. Alright, now let's make some predictions here. Okay, I'll write making prediction. So what we'll do is, in order to make a prediction, we'll just do model dot predict and then pass it our x value. So let's say let's choose the first row. Okay, let's choose the first value from x dataset, and let's see what kind of value it predicts. So we know that the true value is somewhere around 109,000. Okay, so let's see what value does our model predicts. So I'll capture this in this I variable, and then I will print the I variable. Okay, so as you can see, our model has basically predicted the value of 106,000, whereas the real value was somewhere around 109,000. Okay, which is still very close. Okay, so this is how basically we make our predictions. So since our k was 3, So what the model did was, model just from the entire data set, it looked for the three closest values, okay, three closest samples who have the value closest to 8.7, and it took an average of those three samples there. So now if we do another prediction, so let's choose the second last uh, row here, 9.6. Now we know that the original value is somewhere around 112,000. So let's do a prediction for this value and see if we get close to if we make a prediction close to 112,000. So if I run it, you can see that the model has accurately predicted the value as close to 112,000. Okay, so this is basically how you implement a KNN model. But the thing here is that we just randomly selected the value for k here. How do we find the most optimal value for k? So in order to find the most optimal value for k, it's very easy. All we have to do is just train our model, train multiple models on different values of k. So what we'll do is we'll train multiple models on different values of k, and we'll choose the model with the highest accuracy. So let me give it a heading here. So I'll write KNN with optimal k. Let's run it. So now the first thing that I will do is I will choose a set of values for k. Okay, so I'll write k values is equal to, and some of the values that I want here is, let's do it 2, 3, 4, 5, 6, 7, 8, 9, then we'll do 11 and 12. Okay, so let's say these are our k values, and for each value we'll train a single model. Okay, so for each value we'll train a KNN model. So training multiple models is very easy. All we have to do is run a for loop here. So let me copy this. I'll do for k in k values. For k in k values, for each value in k, so for each value of k, train a KNN model, and train a KNN model and find its accuracy. Okay, so we'll create another array called as accuracies, and this array will basically hold the accuracy for all the models. Okay, so what we'll do is we'll simply do accuracy is equal to model dot score, and model dot score will basically take x test and y test, and it will return the accuracy of the model. And once we have the accuracy, all we have to do is just append this accuracy in our list. And once all this is done, we'll print our accuracy. We'll print our accuracies. So let's run it now. So as you can see, we have for each value of k, we have trained a new model, KNN model, and we have collected their accuracy. Now all we have to do is, in order to find the most optimal value of k out of this set of k values, we all we have to do is just create a plot and see which k value gives the highest accuracy. So we can either create a plot, or we can just find the number with the highest accuracy just by finding the highest value in this array. Okay, but just to give you a more visual understanding, I will create a plot here. So what I will do is I will do plotting. So I'll do plt dot plot, and I will, for x I will pass the k values. For y I will pass, for y I will pass the accuracies. So let me also give a label to each axis. So for x axis I will call it as k. For y axis I will call it as accuracy. So now at the end all we have to do is plt dot show, and now let's run it. So here you can see that as the number of k, as the value of k increases, our accuracy drops very quickly. So here you can see that the highest accuracy that we got is for the is somewhere around the is somewhere between 2 and 4. Okay, so what we'll do is we'll train a model with k value of either 2, 3 or 4. Okay, so from the graph we can see that we're getting the highest accuracy at 3. So what we'll do is we'll create a new model with k is equal to 3. So to create a new model, all I have to do is just copy this and paste here. Okay, and what I will do is I will change this n neighbors to 3. Let's see, let's print the accuracy of the model. Okay, so you can see we are getting an accuracy of 97% here. Now this is a pretty good number, but it is very obvious because our data set is not that big. In a real world scenario, you would have to you would have to basically train a very large number of models on various set of k values. Okay, this was a very simple problem here. In real world scenario, it's a bit hard. You have to basically struggle a bit to find the most optimal value for k. So yeah, this is how we implement KNN model. In our upcoming videos, we'll talk more about ensemble methods. Okay.